Hey prepsters, it's Tutor Pat with a quick hit about parallel lines. So before we can talk about how we handle parallel lines, we probably should define them. Parallel lines are two or more lines that never touch. So we can see in our example, right? This line's never going to touch that line. There's never going to be an intersection. The next characteristic is that they are always the same distance apart. So no matter where I am on this line, I'm the same distance from the other one. That is a fancy term. Fancy term is equidistant. They are equidistant from each other. They're always the same distance apart. And the final characteristic worth noting is that they have the same slope. Easier to see when we have lines moving on a diagonal. But if I look at the rise over the run of this particular line, I notice that it is the same as the rise and run of the other. So how do we define perpendicular lines? Parallel lines. They never touch. They are the same distance apart, and they have the same slope. So let's talk about what happens when I have two parallel lines that conform in all the ways we've just detailed, and I throw down a transversal. Now, a transversal is a Latin word. It means a line that goes across, that cuts across the two parallel lines. Now, when I have a transversal cut across two parallel lines, I form a set of congruent angles. So the first thing I'm going to do is I'm going to go ahead and label all these angles created by the transversal. 1, 2, 3, 4, 5, 6, 7, 8. And I immediately notice that 2 and 4 are going to be congruent or equal, as are 5 and 8. Not only are they congruent to each other, they're also congruent to 1 and 4. So 1, 4, 5, and 8 are all congruent. Likewise, 3 and 2 and 7 and 6 are equal to themselves and to each other. So 2, 3, 7, and 6 are congruent. So when I have a transversal go through two parallel lines, I get two sets of congruent angles. Kind of a quicker way to remember that is that the littles, and this guy's little, this guy's little, and this guy little, the littles equal the littles. So the littles in the first line, 1 and 4, will equal the acute angles of the second line, 5 and 8. And the bigs equal the bigs. 2 and 3, that's a obtuse angle. It's going to equal 3, which is going to equal 7, which is going to equal 6. So the littles are going to equal the littles, and the bigs are going to equal the bigs. So we can put all this together when we see a particular shape, or we're told, for example, a trapezoid. A trapezoid, I can use my knowledge about parallel lines to figure a lot of things out about this particular shape. If I follow the extend and pretend protocol. So this is a trapezoid. I know that the top base and the bottom are going to be parallel lines, because that's part of the definition of a trapezoid. So I can extend those lines. That way I can clearly see that they are parallel, meaning they're the same distance apart, and that they don't touch. Then I'm going to pretend. I'm going to pretend there's only one transversal at a time. So I'm going to treat this transversal. And I'm going to note that the littles, this angle and this angle, and this angle and this angle, are going to be equal to each other. Similarly, the bigs, this angle and this angle, this angle and this angle, are going to be equal to each other. That's pretending. And I can do that on the other side too. I can go through here and I can note that the small angles are going to be equal to each other, and the larger angles are going to be equal to each other. This extend and pretend protocol will help you understand figures, find solutions, effectively understand a wide variety of geometry questions on both the SAT and ACT.